Hello, this is the Tepid Coder. In this short video, I wanted to do an addendum to the previous C++ parsing video. I got kind of sidetracked with the debugging I had to do, and there was another change I wanted to make that I didn't end up including. So, if you notice right here, I'm still returning a character pointer, which I have to manage down here and free myself. And I ended up catching an error right here where I hadn't freed it if there was a missing token, so it would have caused an memory leak. I mean, realistically, not that egregious because when I return from the main function, the OS frees up resources anyway. But, you know, just to be as correct as possible, I think it would be nice to have that memory be managed automatically. And there's a couple ways of doing that, but since I'm already including a vector container in here, I was thinking it might be cool just to return like a standard vector, or maybe, better yet, what I can do is I could has a reference to a standard vector characters. So the I don't know, call it file contents. What I like to do in cases like this, I'll turn like true or false if it succeeds or fails, is I like to actually define what I'm trying to do. So let's say out. In, out. So for the parameters, it's unclear what I'm doing with this vector just by looking at the function. But if I say this is an output only, now I know to look at it, this is going to be returned from the function. This right here, it's only an input. I'm not modifying it, I'm only taking it as input and using it somehow. Now if I was going to take some data, read from it, use it somehow, and then also output, I would say it's in and out. And also I include guard these things, well, not include guard, but it's the same concept, right? If it's not already defined, if indef in, then define it indef. Okay, I'll do the same over here. If not defined, out, then define it, otherwise indef. Okay, not otherwise indef, but indef. So do it if it's not defined, otherwise we're not going to do it. So indef, not defined, in and out, then define it, indef. I've seen some people kind of space out like this. Technically, with standard C, you're not supposed to have spaces before it, so I think that's why they're doing it. I'll leave it like that, why not? Anyway, I've labeled my parameters now, so you know that this will only be an input, this is only going to be output. We're not going to read from it. So, first thing I'll do is v file contents clear. So if there's anything already in the vector, this is basically just going to empty the vector. Okay, so here instead of returning 0, which would have been a null pointer, like in C++ you put null pointer, in C you just do 0, or null, capital null is just 0. Anyway, whatever. In this case, the function failed, returning false. If it succeeds, I'm actually going to return true. And what I want to do here, instead of allocating a buffer like this, which by the way, I should have said if not OPSC file contents, then we couldn't allocate the memory, right? That should have been there. Printf cd error. Error couldn't allocate a buffer large enough to read the file, right? I should have done that, and then I should have done a close in, and then I should have returned 0, right? That's what I would have done. You know, that's what should have happened. If I put this on GitHub, maybe I'll actually, you know, fix that. Like, I'll do it right now, so I don't forget. Let's go into Parsing C, I called it. Okay. So in here, I'm allocating that buffer. I should be doing this. There. That's better. And also, I can do that same fix I had before, which is where I couldn't find the token. Right here, so it should free OPSC file contents. Oops. Contents. Just in case anyone ever ends up using it for something. Parsing CP. Okay, now parser.cp. Alright. So back to this. In here, what I'm going to do instead of allocating buffer like this is I'm just going to say v file contents dot, we're going to say resize. Now there's a function called standard vector of type t reserve, but what this does is this actually makes it so that when you're doing standard vector t in place back, or insert, or pushback, dot dot whatever, all of these won't have to allocate memory as soon. It'll just keep pushing stuff in until it needs to change the capacity. So you have like the current size, right? Standard vector t and size, right? Which tells you current element count inside the vector. So you can think of that as being like you can access the vector 0 to size minus 1, right? Those are the valid elements. That's what that is. But there's also the vector capacity, which is how many more elements we could hold currently. And the way that works is usually the vector will double in capacity every time it doesn't have enough room. So like say you have like 0 capacity, it'll probably start with 1, I don't know. You'll put in one element, it's fine, it lets you insert it. But then if you want to insert another element, there's only 1 capacity and 1 size currently, so there's no room. So it has to allocate another node. So it'll double it. Now you can have 2 elements. So you put your next element in, good, now it's full again. Next element, you would need a capacity of 3. Your size is currently 2 and the capacity is 2, so it's going to double. It's going to be 4 now. So you can insert 2 more elements. Once you hit 4, it's going to be 8 elements you can insert, or a total of 8 you can have, and it keeps doubling like that. Anyway, that's what this is for. You change the capacity. But even though the capacity's changed, if I reserve, let's say, 100 bytes, I can't just access the vector position 1 even. It doesn't actually let me use that. But if I use resize, I can use it right away. So I'm going to resize to UI32 file size plus 1 for the null terminator, and 0 is what I'm going to initialize every value with. So remember, this is a vector of characters. So each of these characters is going to get the value 0. I could look at it as like being that, but that's the same thing as this, right? It's like the character 0, which is just an integer value. Like on Microsoft Visual Studio, a char is basically just an int8t last time I checked. Maybe it's changed between compiler versions, don't know, don't care. Anyway, this should give us enough memory. And technically you should probably put this in a try catch block, because it's not going to like return false or something if it fails to allocate the space. What you could say is like, return false here. You could even show the error. Yeah, think of something like standard error. Oops, error. We would say exception. Okay, and then e.what, which is the most bizarrely named exception string accessor I've ever seen. I would think it'd be like cstr or something, right? Like instead of string, but it's not. It's e.what, which actually just returns a const char star. I would kind of expect like maybe a string or something, or maybe a const string reference. I don't know. Whatever. It is what it is. What this would actually return is a standard bad alloc, but that derives from exception, so I could just catch the base exception and use that. That works just as fine. Anyway, so if we fail to allocate enough space, we're going to return false. Another thing is, probably we want to close the file before we return. Otherwise, we're leaving that file handle open in the OS. That can cause issues. So, yeah, if we can't open the file, we fail. We might even give a message there, right? Like, standard error couldn't open the file. Alright. Fact, yeah, I'll leave like that's fine. File name. Really, it's file path. Could be the file name that's relative path you're using, but I usually call that file path. Okay, what else? Okay, so at this point we've allocated enough characters inside the vector that we can fit the whole file, plus 1 null terminator, and I've initialized all of the characters to 0. So the null terminator at the end is already a 0. So I don't need to worry about any of that anymore, or that, but I need to be able to say where the buffer is. To get that, you say vector name dot data. So that's where the memory address of the vector data is. This will point to the first element of the vector. So the first element of the vector is going to be a char type, right? So since it's a vector of characters, really this block of memory is like a char array, or a char pointer. So this is going to give me a char pointer to the first element. So let's pretend it's like a char, I don't know, C array. It's an array of characters, right? Say I have 10 of them equals ... whatever. If I say that I want like the first element, a pointer to it, it would be something like and C array 0. Or since this is already, pointing to the first element, I could just say it's just C-array, right? That's what's happening here. When you go to call the data function, it's just returning this, the first element, which is just, this in this case. Anyway, so we're going to fill the vector with the file contents up to the file size. So all the bytes of the file get pushed in there. And then it has one extra element at the end for the 0. Okay, so we're going to return true if it succeeds. So in this case, we need to change how we access this. So we have a vector of characters. We're going to call it vector v file contents. Okay. We're going to say if not loaded file. See, I wasn't even testing to see if the file properly loaded before. I was being kind of lazy. We'll return an error here. Def standard error. Couldn't load the file. Giving up. Okay. And if it did work, then the file should be loaded into this vector. Now remember, the vector automatically freezes memory when it goes out of scope. This is the scope, right? Start of the main function to the end of the main function, right? Okay. So, at this point, we don't have to free the file contents anymore. It's done for us. So that's way easier. Let's see. Go over to, oops, doesn't have that, so it's going to be, what is it called? Parsing Addendum. Okay, and then G++, parser SCP, output is going to be parser. Did not mean to do that, it should be parser, but yeah, we have errors anyway, so let's run that. So it started on line 52. Oh geez, what was it? Control caret or something? That's control underscore. No? Control shift underscore, okay. 152, okay. So it's not happy with that. For what reason? What does it say about that? Oh, contents, plural. Oops. Fair enough. So what we're going to do here is going to say, compile it, line 70, too few arguments. That is true. Okay. Line 70, wasn't it? Yep. So you have to pass the vector we're going to fill. File contents. Okay. Okay, so line 78, not clear to the scope. That's true. You got me there. So what we're actually printing out here, it needs to be v file contents, so we're going to do .data again, right? And just for fun, I'll show you that you can do the same thing if you just do this. Let's say the first element and reference the first element. That'll do the exact same thing. What am I doing? I'm going to do that back as it was and just go over here to compile it. I have to remember that I can't compile it with git bash because the environment's wrong. So 82, same problem. So over here, it's going to be vector file contents dot data, or it could be, like I said, v contents, file contents rather. Position 0, and then reference that first element, right? Okay. Why do I keep doing that, man? Gosh darn it. Okay. 94, same thing. Okay. Don't need to free it anymore. The vector does that for us automatically. Clear it. Alright, now it compiles. And there we go. Works just the same. So what did we actually accomplish here? So the main thing we accomplished is that we don't have to worry about freeing the file contents that we allocated on an error here and at the end of the file. So anytime there's an error, you'd have to worry about freeing it. But we don't have to worry about that anymore. It's just done for us. And yeah, there's a lot of things I want to delete from here. There's just notes from the previous, what do I say, the previous video I did, right? I kind of leave that, kind of want to leave that debugging stuff in here though. Yeah, so I think that's probably where I'm going to leave it for this video. I just wanted to show how much easier you can make memory management. And I think I've probably accomplished that at this point. I mean, there's small things I could do as far as, like, if I were to load the file into a string instead of a vector, I could be using different functions to search for things, but there's no real reason to do that. The only difference is, like, you use, like, stir find, like, standard string find, is it'll return stir in pos if it can't find it, right? In this case, this is returning 0 right? It returns null or 0 or null pointer if I can't find it. Anyway, whatever. If you found this video useful, then please feel free to like, comment, subscribe, do whatever you gotta do. I will catch you guys later.